I'm Anil Kumar sharing with you an excellent question from previous test paper. Let us see how to solve this question, and I hope that helps you to get better marks in your own test. We are discussing vectors. Submarine A is at -54 and fires a torpedo with the velocity vector 3 minus 1 at exactly 1:34 p.m. Submarine B is at 15:07 and A minutes later can fire a torpedo in the direction -4 -3. B's torpedo is successful in knocking out the A's torpedo. At what time did B fire its torpedo? When did the explosion occur? Write answers to 100th second. That's the question for you. You can pause the video, answer the question, and then look into my suggestion. Now, in such questions, we need to write the displacement vector equation for both the torpedoes, and then we can find their point of intersection. So for submarine A, let's write down for submarine A first. We have the position given to us as -5, so we say R equals to -5, 4, and fires with the velocity vector of 3 minus 1. So that is the velocity vector. We can write this as t times 3 minus 1. So that becomes the vector equation for the position of the torpedo, right? Now this is fired at 1:34. Let's write down the equation for the second one, which is B for us, and that is R equals to, the position for the second one is B is at 15:07, so it is at 15:07 plus S times it could fire in the direction of -4 -3. That's what it's given. Now here it is important to understand that we are also given one more parameter, that is submarine B is at 15:07 and A minutes later can fire a torpedo in this direction. B's torpedo is successful in knocking out A's torpedo. That means they have a point of intersection, right? And the relation between S and T is that in this equation, let me write T is greater than or equal to 0. And of course, in this individually, S will be greater than or equal to 0. But what is really happening here is that at the instance when the torpedoes meet, we are saying that B can fire A minutes later, right? So there is a time difference between the two. So if I have to link these two equations, in that case, I have to remember that S is basically equals to T minus 4, right? Since B can fire A minutes later, right? That is a response to the fire from A, correct? Now with that in view, we can write the parametric equations for both, correct? So for the first one, we can say X is equals to -5 plus 3t and Y is equals to 4 minus t. And for the other equation, you can call them as x1, y1. And for B, or you can say, let's better write xa and ya. So for B, xb will be equals to 15. So instead of S, if I use t minus a, then we get the same parameter and we can actually find the value of t, right? So it is 15 plus, I should write minus, okay, -4 times t minus a. Does make sense to you. So S I am replacing with t minus a, and yb will be equals to 7 minus 3 times t minus a. Now these equations, since we see it is successful in knocking out, so successful in knocking out means they should be equal, right? So that gives us a solution for T and A. We have two equations and two variables, right? So that should not be very difficult. You can pause the video, answer the question, and then look into my suggestions. So let's solve. So we have now minus 5 plus 3t equals to 15 minus, let's open this bracket, right? So I'm opening this bracket, minus 4t plus 4a, right? And we can rearrange this equation, bringing 4t this side and 4a this side. So we get, let's say 3t plus 4t minus 4a equals to constants to the other side, 15 plus 5, or we can say 7t minus 4a equals to 20. Right? So we get one equation by comparing the x values, x coordinates, right? Now let's compare the y coordinates and get the other one, correct? Okay. So comparing y coordinates, we get 4 minus t equals to 7 minus, we'll expand this, 3t plus 3a, right? So that is, bringing this t to the right side, we get 3t minus t minus 3a equals to 7 minus 4, which indeed is 2t minus 3a equals to 3. So now we have these two equations to work with. And these two equations in two variables can be solved to find the value of t and a, right? So that's the whole idea. So from here, we can find the value of t and a. So 7t plus 4a, 2t minus 3a. I could multiply the first equation. Let's say we want to eliminate, a, for example. So I'll multiply this one by 3 and this one by 4. Let's do that. So multiplying this one by 3 gives us 21t minus 12a equals to 60. Multiplying this one by 4 gives us 8t minus 21a equals to 12, right? So we get this. So what I did was I multiplied this equation by 4 and I multiplied this one by 3. So the idea is we get these two same, and when we subtract one from the other, we could solve. So let's subtract these two equations. So I'll do this equation, take away that. So I'm doing this operation now. This minus that. So 21t, okay, let's rewrite. So what we have here is 21t minus 8t equals to minus 12. This was 12, I'm sorry. When you multiply by 4, you get 12. Minus 12 cancel off. So we have 6t minus 12. Correct. So that gives us 21 minus 8. Let's use calculator. Okay. So 21 minus 8 is equals to 13. So this implies 13t equals to 60 minus 12, and that is equals to 48, right? So we have 48, so we are running into decimal values. So t is equals to 48 divided by 13. So that is the value of t. Now t tells us the time when the explosion happens, correct? T is the time when the explosion happens. These are the two things where they intersect, right? So for t we get that. Now substituting t, we can actually also find a. So let me use one of these equations. I didn't number the equations, so it's becoming slightly difficult to explain. So I'll use this equation now, which is 2t minus 3a equals to 3, and I'll substitute t as 48 over 13, right? So we have 3a, we'll just solve for it. 3a equals to 2t minus 3, and a will be divide this by 3. Okay, so that is what we have. So in our case, we have t as 48 over 13. So we'll have 1/3 of 2 times 48 over 13 minus 3. Is it okay? So that is what we have. And let's calculate this value. So we'll do 2 times 48 divided by 13 equals 2. We'll take away 3 from here, and then we'll divide all this by 3. So we get A as equals to 19 over 13. Is that okay? So that is the value of A. Now we need hundredth of seconds, and this time is in minutes. So this time is in minutes. To convert this into hundredths of seconds, we'll multiply this by 60 to get seconds, right? In decimals, we have this as 87.69 seconds. Do you see that? So that is in seconds, right? Obviously 1 minute and some seconds, right? So if I take away 60 from here, we know how many minutes, right? Okay, so so if I take 60, we know 27 seconds, right? So it is 1 minute 27 seconds. Okay, so we could write 1 minute and 27.69 seconds. Okay, that makes sense. Similarly, for t, we can find the time as 48 over 13. So let's do 48 divided by 13. So we get in decimals 3.69. So it is 3.69 minutes. So we have 3 minutes, and in seconds we do 0.69 times 60. Okay, so in decimals we get 41.4. So actually I should do, wait a minute, 48 divided by 13 equals 2 in decimals. So it is 3.6923, right? So anyway, so we'll do 69, we'll take one more decimal place, and then 0.692 times 60 to get hundredths of minutes, seconds, right? So we get 41.52 seconds. Do you get an idea? So that is how we can find both the answers. So the question is, at what time did B fire the torpedo, right? So first is firing the torpedo, right? So fire happens after A minutes, right? We started at 134, so it is 134 plus how many minutes? 1 minute. Let me write 0, 1, and 27.69 hundredth of second, right? That gives us the time as 1:35 27.69. So this is the time when it was fired. So we added A value to it. And explosion took place at 1:34 plus 3 minutes. I should write 0 plus 0.3 and then 41.52, right? So that gives us the time as, so when you add 3 minutes here, so it is 134. I'm sorry, so let me use a different ink. So it is 1:37 minutes 41.52 seconds. Do you see that? So that is the explosion time, and that is how you can solve this question. I'm Anil Kumar, and I hope you learned a lot from this video. You can always share and subscribe my videos. Feel free to post questions. Thank you and all the best.